All right, y'all. Let's finish up these notes and do the last three properties that we have for our exponents. All right. So next one we have is going to be over here. This is our quotient rule, or our quotient property. So let's take a look at an example and see what that looks like. Okay, so just like we did with the other questions, we're going to expand these out so that we could see everything. So we got x to the 7th, so that means we need 1, 2, 3, 4, 5, 6, 7 x's on the top. And then we got an x to the 3rd, so we need 1, 2, 3 x's on the bottom. Okay, so looking at these are all x's. We have the same thing on the top as we do on the bottom, just a different amount of them. So what we could start doing, once we have the same thing on the top and same thing on the bottom, we could cancel these out. So we got that canceled out, we got this one canceled out, we could cancel this one out as well. So that's going to leave these up here. Okay, well, that's 4 x's, so we could do x to the 4th power as our answer, because there are 4 x's left over. So let's think about this. What did we do with the 7 and the 3 to get to 4? Well, it looks like we subtracted them. 7 minus 3 will give us 4. So that will be our rule. If we have a situation like this where we have our fraction bar, we can say that our base x is going to be our top exponent minus our bottom exponent. So we have x to the m minus n. So let's use that to solve the rest of these. So let's see, let's go down to number 2. We have p to the 8th over p to the 5th. All right, well, I know we're going to take our base. We want our first or top number, or top exponent, minus our bottom exponent. So that'll be p to the 3rd power, because 8 minus 5 is 3. All right, let's do the next one. We got v to the 9th over v to the 3rd. So let's see, I'm going to keep my base of v, and we could do 9 minus 3. So that'll be v to the 6th power. All right. That is our quotient property, and this one is going to be important to the other 2 properties so we can kind of understand what it is. So at the bottom of this quotient rule, I'm going to come up with an equation, or actually I'm going to put it up here. I'm going to come up with an equation. All right, so let's say we have x to the, this is going to be a little too big, x to the, let's say 4th power over x to the 8th power. Let's say we have that. So if we were to solve this, we would get x to the 4 minus 8. Okay, well, that's going to give us a negative 4 as our answer. Now, when we do this, or when we separate this out, when we expand it, we could see what's going on here. So we have a negative exponent because we have a bigger number on the bottom of our equation than we do on the top. The name of this next rule is going to be the negative, oh my goodness, negative exponent. Gracious. Exponent rule. Okay, so this is the negative exponent rule because we are getting a negative number here. So like I said, when we expand this out, we can kind of see what's going on here. So let's do that. let's do this over again, but instead of just going with our direct rule, let's just write the whole thing out and see what's up. So I got 4 x's on the top, and I need 8 on the bottom. So we got 1, 2, 3, 4, 5, 6, 7, 8. Perfect. All right, so we got 4 on the top, 8 on the bottom. Okay, when we start canceling out, let's see what happens. We got this guy, this guy, this guy, this guy. Okay, so we have 4 left over, just like it says, but they're on the bottom instead of on the top. So that's where we get that negative from. So when we write out this answer, we are going to have x to the 4th power, but it has to be at the bottom of our fraction because that's where it is in this problem. So that was all the work for number 1. So let's put that, oops, move that over there. Here we go. So that we could see what we did. So how this is a situation where we would get a negative for our answer like we did here. This is why it looks like that. We had all of our x's left over on the bottom instead of on the top. That is why our answer has to look like this, with a 1 over x to the 4th power. And that will be our rule for this negative exponent. So if we have our base x and our m is negative, that means that negative is telling us it is at the bottom of our fraction. And we have to keep it at the bottom and clearly show it's at the bottom. We do not ever want to have a negative in our answer. So make sure that once you do this, your m turns into a positive number. So let's try this with the rest of these. We got number 2. That's an h to the negative 2 power. So we're going to change it into a fraction with our base at the bottom, but make sure to make that exponent positive. All right, number 3 is going to be similar. We have an a to the negative 7, so we want it to be a fraction with our base at the bottom and a positive exponent at the bottom as well. This one's kind of weird, but like the main thing is that if you have a negative exponent, you're going to end up having a fraction that looks like this. Okay. Last one we have is going to be our 0 exponent. So what happens to get an x to the 0? Well, let's see. So let's use that quotient rule one more time to see a situation where we would get a 0 in our exponent. So we might have something like x squared. Let's fix that. X squared over x squared for that to happen. Because if you just subtracted these two, you would end up getting x to the 0. But let's see what happens when we expand it. Let's see what that's going to look like. So let's say we had x2, x2. Okay, so we got 2 x's on the top, 2 x's on the bottom. Alrighty, so when we cancel that out, everything is gone. We canceled this, there is nothing left. So, thinking back to the way back, if we have a number that is divided by itself, that will equal 1. If we had 2 over 2, that would be 1. If we had 3 over 3, that would be 1. So if we have this turned into a 1 and this turned into a 1, that means that our answer should be 1 because everything just got canceled out. If you just look at this first part, we could see that we have an x squared over x squared. These two are the same thing, so we could just automatically cancel those out and turn them into a 1. So our rule for our 0 exponent is that if you ever see a 0 in your exponent, your answer should be 1, no matter what. So for our examples for this one, this is the same thing. We got x to the 0, that's going to be 1. If we have f to the 0, that's going to be 1. If we have 2 to the 0, w to the 0, that's going to be 1. Always and forever, it will be 1. All right, so that is all of our properties that we talked about in class, thus all the notes. So what I would do is look on Teams and try to practice a little bit more in case you weren't here. But we're going to talk about this more throughout this unit. I think that's it. I hope y'all have a good day. Let me know if you have any questions. Bye.